Thanks, and good morning, everybody. Thanks for having me here and giving me the opportunity to speak a little bit about Qt as a C++ framework. I'll talk a little bit about where we're coming from, where we are today, some of the philosophies, design principles behind Qt, because they, to some extent, also differ a bit from what you know from maybe from the standard libraries. And also have a little bit of an outlook, where we're going. Let's see how this goes. For quick information, to get a quick idea, I mean, how many of you do know Qt and have used it before? Wow, thanks. That's great and fantastic. So I'll probably be telling you a little bit of stuff you also already know. But let's see. We'll keep the thing short. But I'll still have a little bit of an intro about what Qt really is, what we have, and let's keep that one short. Everything else you can see, I'll look at. It's probably the most comprehensive C++ framework available today. But it's not only that. It's not only a C++ framework. We also have other things in there. We have a lot of tooling around it. We have things to help you create embedded devices. We have a UI technology called Qt Quick, which is not C++, but integrates very well with C++, and I'll come to that a bit later. So there's a lot of stuff in there, and in the end, it has pretty much everything you need to do and to create your applications for whatever use case it is. It's dual licensed. We have a commercial version available, and there's also a commercial company called the Qt Company behind a lot of the development efforts around Qt. But it's also available under a combination of LGPL versions 3 and GPL versions 3. We're developing it fully out in the open. It's an open source project, the development. As said, a lot of the development is done by the Qt Company, but we do have a lot of external contributors as well that help us, develop Qt further and contribute whatever is important to them to Qt. We currently have two products, basically, that come out of that one. One of them is called Qt for Application Development, which covers pretty much all desktop and mobile platforms that are in use today. We have Linux, Windows, Mac OS, and on the mobile side, iOS, Android, and also Windows Phone, if you're still using it. In addition to that, we had over the last years an increasing focus also on the embedded side, where we're seeing a lot of usage coming up. We're seeing many more people that want to create applications, complete devices that have a user interface, that have a touch screen, where Qt is a very natural fit. And we're supporting most of the embedded operating systems that are in use out there, let's say for anything above the microcontroller level. So embedded Linux, QNX, VxWorks, Windows IoT Core, Integrity. Let's have a little look at what's in there, and that's what I meant by comprehensive framework. The application development side is based on top of a platform abstraction layer that abstracts away the different operating systems and their differences. That's what you see on the bottom here. On top of that, we have a set of essential libraries and frameworks, as we're calling it. It starts with Qt Core, which has the foundations, tooling, classes, threading, file I/O, you name it, everything non-graphical. A GUI library, which are the foundations of graphical things, painting, text, font handling, anything related to these kind of things, PDF generation, lots of other stuff in there. And then on top of that, we build up different things, widgets for classical desktop widgets. We have a SQL module. We have other things. We have our Qt Quick UI technology, multimedia, sensors integration on mobile devices, for example, and lots of other things. As you see, the list is comprehensive. And then complementing that, on the right-hand side, development tools are mainly centered around our Qt Creator IDE. But we also have an integration, for example, into Visual Studio, and where we provide things like graphical designers, development help for C++ developer, like Clang static analyzer integrations, profiling, debugging, remote debugging on embedded devices, all those kind of things. So that's the application development product at a quick glance. The other product, device creation, is something that is there for the embedded device, where we basically add on top of Qt for application development. It extends application development. So what you see on the bottom is basically what you just saw before in the application development slide for the embedded platforms. And then we extend that with embedded specific solutions like a virtual keyboard, support for different serial buses like CAN bus, Modbus, software stack boot to Qt, where we make it easier to integrate on an embedded Linux device, and embedded tooling like running a device emulator locally, building for that one and debugging on that one, remote debugging on the device, and these kind of things. So that's at a glance the product. As I said, one of the main corner parts of what we're doing there is the Qt Creator IDE. This is really the center part of our offering, which many of our people use. It's a full cross-platform IDE. Works the same way on all desktop platforms and has support for Qt projects. And we also know a lot of people who are using it purely for C++ projects. They're not even using Qt, but they're using Qt Creator as their IDE because it gives them the cross-platform aspect of things. As said, lots of things in there, code editing and compiling. Now with the latest releases, we have added support so that, we're basically giving you immediately inside the source code compiler warnings and errors. So you see that, can see that, for example, here. This is Qt Creator, the current version running. If I go here, for example, we're seeing, you don't see that. I need to get out of the presentation for a second. Here we go. Is that working? No, it's not. Problem with the second screen. Sorry, doesn't seem to work. Let's stay with this one. But you have inline code editing there and inline warnings and error messages. So that's a little bit it. I can at least show you a screenshot of Qt Creator, a little bit older version, where you see the code editor, project management, you see the debugging panes, all of that, and everything you need. Okay, so much for a very quick and rough overview over what Qt is. But let's go a little bit back into history, actually, to be exactly, let's go 26 years back. Let's go back to a park bench in Trondheim, Norway. That's where it all started, actually. There were two, students at the university in Trondheim called Eirik Schambeng and Håvard Noor. And they were actually working there on their thesis in 1991, 1990, and had to develop a graphical application at that point for Unix and for the Macintosh, the early versions. And they got extremely frustrated with what they could find there in terms of tooling and help. On Unix, it was X11. There were Athena widgets, Motif. And they tried using that and felt like, this can't be really the solution. This is hard to use. It's very hard to debug, work with, and it just doesn't feel right. So, they sat down on that park bench at some point and said, okay, this is not working. What we really need is we need not some C APIs. We need an object-oriented presentation system, a display system, something that that makes our lives easier, that helps us bring these applications onto the screen. And that also a little bit defines what the real goal there was in the end. It was about, making software development fun and easy. That's something, that was missing at that time for them, and they felt like, software development is really hard. It's no fun. You get home, it doesn't fulfill you. So how can we change that? How can we make it actually fun and easy for developers to work with software, to work with graphical applications and get those out and get those developed? And, after that talk, it took a little while. They were talking a bit around and sending that. And you see a diagram here that was from 1993 when they started, developing their ideas a little bit more, where you see a lot of, what made up, the first version of Qt and what they were thinking. Also, a little bit interesting, you see now where the Q comes from. The earliest version there was actually called Quasar. That was the idea they had for the name. In addition, there was the thing that the Q was nice and it wasn't taken as a prefix letter because, there was X for the XT widgets. Motif had its own prefix. So, namespaces didn't exist at that time. So what do? You pick a letter and you use that one and, occupy that as your namespace. That's what happened. And it's interesting to see that if you look at the design, a lot of things are still available there in Qt today. You have the Q object as the central piece, really smack in the middle there on top. A meta object that's helping you manage, the signal slot mechanism, which is something that actually Eirik and Hova invented in the times and has been picked up by many others afterwards. Seeing event handling at the bottom. And on the right-hand side, you see a font, a painter, colors. So the basic things you need to build up, a graphical user interfaces. And they took that forward, and in the 1994, they managed to convince their wives to sponsor them for a while, and founded a company called Trolltech. Here you see one of the earliest versions of the website. So they were starting off from the very beginning, which was actually unusual there by, basically marketing everything through the internet. The World Wide Web was very new at that time, so it was actually something that wasn't quite usual. They never really sold physical copies, which was the standard distribution model at that time. If a customer asked for that, then they went and burned the CD-ROM and shipped it off. But by default, you download the thing from the internet, and that's how this works. So it was very interesting. And in April '96, they then actually made the first sale of a Qt license. It was the European Space Agency that purchased 10 licenses to make some satellite simulation software. It was pretty interesting and actually, an interesting decision and a gutsy decision by them because Qt wasn't even at version 1.0 when they did it. And Trolltech had 4 employees. Then, Eirik sat down and had to make an invoice. And he didn't even know how to do that. So he took an invoice from somewhere else that he had gotten, copied it, basically made it look approximately the same, and then, looked at it and said, oh, but, I can't write invoice number 1. That just looks wrong. So he went over to Hova and asked him, oh, what should we do? He started, let's put it invoice 211 in there. Sounds like a decent size, and it's a prime number. That's cool. So that's what they did. And so the first invoice started actually at number 211. And then they had a couple more, but by the end of the year, they felt like the numbers looked too small, so they added 1,400 to them to make it a bit bigger. Trolltech sold internationally from the very, very beginning. The first 8 customers that the company had came from 8 different countries, and not one of them was from Norway. That was actually pretty amazing. It was a good start. Qt 1.0 was then released also in 1996. At that point in time, C++ was still pretty early, so Qt 1.0 worked completely without templates. Nothing in there. They had, specialized specialized lists for pointers, for integers, for 3 or 4 types that they needed, and that was it. Also, interestingly enough, they started from the very beginning and released, worked cross-platform. The version was working on Windows 95, and on Unix. And they released the Unix version with the source code out there under nowadays you would say an open source license. It wouldn't be open source approved license nowadays, but it was there and it was free for everybody to download and use for non-commercial purposes, which was also in a way a marketing instrument to, because there was a small company, no marketing budget. How do you spread the word, right? Well, give out the source code and let's see what the currently building up and emerging open source community around Linux would do with it. And actually, something then magically happened. In '97, a guy called Matthias Ettrich actually, got fed up with the state of user interfaces on Linux. At that point in time, you had, I don't know who of you remembers that FWVM, and very old, just window managers. You could move some windows around on X11, but you didn't really have a windowing or a desktop like Windows 95 had. And he wanted to change that. And he said, I want to change that. I want to do a project there. And he announced it as, I'm on a news group, Comp OS Linux MISC at that point in time. I don't know, many of you probably have never, the younger ones have never seen and worked with or seen news groups. But they were one way of communicating things out there at that time. And he basically announced that, that he wanted to start that project. And, some quotes from there, where he said that I want to use that Qt framework. I want to use Qt for it. Because since a few weeks, a really great new widget library is available, free in source and priced for free software development. Check it out at www.troll.no. The stuff is called Qt, and it's really a revolution in programming X. It's almost complete, fully C++ widget library, and it implements a slightly improved motif look and feel, or switchable during startup Windows 95. Good stuff. And he started that. He managed to attract quite a lot of people, especially in Germany at that point in time. And they started working on it. And half a year later, they had the first version of KDE up and running, a desktop for Linux. Fantastic. And it was actually a revolution. And it, in some aspects, actually, it was a lot more rough on the edges and not as complete as maybe Windows 95 was. But it started providing something. It had a panel down there, something to launch graphical tasks, control center, help browser. It had a browser, file manager. So the basics were there, and it started picking up greatly. And lots of people started, using it and extending it. An open source community formed around it. And if we look at it in hindsight, this is probably why Qt really took off, became successful, and why we're still here today using the framework. 1999 then, that was a little bit after I became a user of Qt, which was in '98 approximately. Trolltech released Qt version 2.0. And they found out, we did some larger changes there. Biggest one was we move over to Unicode. We have 16-bit strings, and that was all that was required for Unicode at that point in time. And they changed the license to GPL. Had a first version on embedded Linux running on the frame buffer. And on the business side then, Trolltech received the first round of venture capital funding. So within a year from end of 99 to end of 2000, the number of employees grew from around, a handful to around 50. So large growth. That's also when I started working for Trolltech at that point in time as a software engineer, working mainly on internationalization, Unicode support, bidirectional text, complex text layout. That was my initial stuff where I worked a lot on, and got started. Actually moved to Norway for that job and got stuck there. We soon also saw the need that, you could easily create user interfaces with C++, but you had to all stuck it together, and define in C++ how the look should be, how you arrange your widgets, whether that line edit is on top of the button or below, to the left, to the right, using a mechanism they had in there that was flexible called layouts. But many people said, this is a tedious work. I want to see it graphically, and I don't want to have to recompile before I can see it again. So we worked on a first version of what we called Qt Designer, the UI designer, to help you there. And that's probably a slightly later screenshot of it, but it's something where you can graphically put your user interface together, and then later on use that in your C++ projects. Moving forward in history, Qt 3 came out in 2001. Did a bit of changes there. In Qt 1 and Qt 2, our string class was explicitly shared. Figured out that was a problem for many users. Many subtle bugs came in because people started modifying that string, and then it got modified in a completely different part of the application as well. So we moved over and said, okay, let's move to implicit sharing, where we basically detach whenever the string gets modified. We started using templates more. The compilers were catching up to C++ 98. We still had to deal with Visual Studio 6. Some of them, you might remember that one, which wasn't very good. But we started introducing templates, value-based containers. We moved and started having a system where we could upcast our QObject hierarchy to the concrete instance using QObject cast, because RTTY was still in its infancy there, and it wasn't working reliably across, for example, shared library boundaries. And we started working on the Mac and open source Qt for the Mac. Then, let's fast forward a little bit. In 2005, we moved over to Qt 4, where we did a major overhaul of those template and tool classes. Many of them in Qt 3 were still, based on pointers, so you had to new every object that you wanted to stick into a container, leading to larger issues with memory management and other things. So we moved them to be value-based, and we made the implicitly shared classes. We added atomic ref counting to that. I'll come back to that a little bit later and talk a bit about that one. And as the final thing, we open sourced then also the Windows version. That was the last version we actually open sourced. Since then, everything has been out in the open. But, we were for a long time as a small business, growing. We needed to get revenue, and not open sourcing Windows was seen for us as an insurance that we would get, the customers that we needed to survive. Yep, things grew further. We had a lot of things going on in the open source community with KDE and others. Also, some competing projects to KDE popping up with GNOME, and lots of things going back and forth. But, for us, things moved forward, and then at some point, we actually got one of these tech giants interested in us. Nokia was looking at us. They needed a technology to unify, to unify their different platforms and have a unified API for their developers. They were thinking about, okay, we need to have a developer offering. I mean, this was still, a little bit before the iPhone when those decisions were made, but they saw that they needed a developer offering and then a unified API so that they could move from where they were with Series 40 and Symbian over to what was, at that point in time, their long-term strategy, a Linux-based stack called MyMO or MiGo. They did a huge investment, and that was something that really helped and pushed Qt forward. We were doing, the Qt Quick UI technology, for example, as the first versions. We had, for the longest time, all of the R&D in Qt, we wanted to do an IDE. We said, this is cool, we want to do it. Management in Trolltech always said, maybe not, there are other IDEs out there, why don't we use Eclipse? There's Visual Studio. But we were itching for it, and we thought that this is bad because we don't have a good cross-platform IDE, and Eclipse was really not very usable for C++. So we wanted to do it, but never really had the funding. With Nokia, we finally had that. And we went in and pushed forward with Qt Creator. We worked on a WebKit integration where we basically integrated the browser engine as one of the frameworks that we offer to people, so people could, basically instantiate the browser engine and use that within their application. And Nokia did another thing. They changed the open source license from GPL to LGPL, making it much freer, and also, with that, increasing its use probably tenfold. So we got a lot more people to use Qt through those changes. But unfortunately, not everything went as it was supposed to go. 2011, we had a burning platform. At least that's what our CEO told us at that point in time. We were just about getting ready. It was a hard fight inside Nokia. Big. You have a big ship, a big, huge company, and we were trying to, bring Qt in there as the framework for development, both in-house but also for third-party users. We had things ready. The Symbian was there using it. We had apps going into the Nokia App Store using Qt. The N9 MeeGo device was almost out, but management didn't believe this could work out. Said we had a burning platform, we needed to hop off it. We did. We hopped over to Windows Phone, which meant that Qt actually had no role inside Nokia anymore. At least not a big one, a minor one. So for us, this was clearly a large setback, and something that it took a while to recover from. But it led ultimately to the fact that then, a year later in 2012, we actually separated ways from Nokia and, got bought up by a small Finnish company called Digia. At the same time, we were then also working towards the current version of Qt 5, where we did larger changes again. We looked at, how have we so far been doing platform integrations. And the one thing we learned in Nokia is doing that porting Qt to a new operating system was extremely difficult. We didn't have the right abstractions in place. And, that Symbian port used up a lot of manpower. So we wanted to change that, and we did a new abstraction underneath that makes it very easy to port Qt actually to new architectures, called the Qt Platform Abstraction. And that's the one that actually also then later on allowed it for us and made it relatively easy for us to then move over to and implement Android and iOS support, or support for many different embedded operating systems. We also had a lot of work on touch-based user interfaces that started already during the Nokia times, and we saw that we had a first version of our technology there. The need for that one came also in through different things where we saw that widgets that we had as UI technology so far were very good, but they were mostly limited to static user interfaces. We tried to put animations in there. For example, we had a main window framework where you had dock widgets and these kind of things, and we tried to make it animated. So when you move a dock window and hover it over a certain place where you might want to drop it down to dock into, it would make space there and it would animate so you'd see where it would drop. It took a developer a year to get that implemented, and it was really, really hard code to maintain afterwards. So we thought about how can we do that differently, because our users have the same need. That led us to Qt Quick. So we moved there, we brought that forward. We saw that we needed, also here with Qt 5, that we needed to bring that on top of a GL scene graph to really get the best performance out of the hardware. Because you're doing animations, you're doing lots of graphics, it needs to perform. People expect it to be fluid, like on fluid animations like they were seeing on the iPhone. And that's something we needed to do there. And we started having a larger focus also on the embedded systems, because that's where we were seeing that there was a lot of demand for solutions. People want to use C++ on embedded systems, but there wasn't really any good solution to do user interfaces. And during that time, we also started opening up our development under open governance. Now, from that time onwards, Qt was being developed as an open source project. Before, we were working in Trolltech. We developed everything in-house, and then we basically released the final versions as open source. But as said, we moved out from Nokia, got acquired by a small Finnish company called Digia. and were there for a couple of years until we last year split ways with Digia. And since then, the Qt company is a fully independent company listed on the Helsinki Stock Exchange. And we're focusing fully now on Qt as a product. Just now, final slide on business. Just to give you an idea, the Qt company today we're around 250 employees, around 150 of those technical, have a revenue of 32 million euros, and around, Qt has currently around 1 million active users. So it's big, it's quite a lot. Okay, so much for history, so much for companies. Let's move over to something else. A little bit on the philosophy and how we are developing Qt, what we're doing there, what's important to us. First thing is we want to empower our users with the technology we have. And that goes back to the original thing that I said, what Eirik's and Håvard's vision was. Software development should be fun, it should be easy. Make a product that's as versatile and flexible as possible. Give developers the tools they need, let them be in control. Make it easy to use Qt, have, for example, world-class documentation so they can find everything. But also try to make it so easy that they don't really need the documentation in the first place. Give people freedom, with Qt, freedom to innovate, extend Qt, do things on top of it, integrate with other frameworks from the side. We don't want to limit anybody, how they do their application, how they do what they need to do. If you want to pull in a third-party library, do that. So make it easy to integrate with other technology, and also, as a freedom, don't attach any strings to our product. Use it as you like. And from our point of view, also the freedom nowadays is also that we are independent. Most of the development is done through the Qt company. A small company, we're independent. We have no affiliation with any of the major tech giants. Meaning, our agenda is really helping our users and nothing else there. Continue with open source. As said, we have always been open source, and we'll continue doing that. All our development is in the open, and the development is done on Qt project. It's a meritocracy, so anybody who has an interest and who wants to can gain influence there. He can become involved, gain influence, maybe also become an approver for changes, can start reviewing other people's changes, can become a maintainer for a certain area. So that's very good. It also allows our users and our customers to see exactly what we're developing. We're not hiding anything. You can follow every change. You can, git blame on it. You know what's happened. You know who's responsible. You can contact the developer and see, why did you do that? I'm having a problem with this piece of code. All of that is possible. Here you can see a little bit of a statistics on Qt project and the contributions. So you see that, the percentage of commits and where they come from which companies. So you see that the majority is still coming from the Qt company. But then there's other companies, and you have a large set going up then of smaller people, individuals contributing. This also has changed over time. Some years ago we had a lot of contributions from BlackBerry. Those have a little bit died down because they don't have a mobile phone anymore, or a mobile OS of their own. So things are changing, then new people are coming in, but it's going forward, and it allows people to really contribute their own things. Cross-platform, as I said, is also extremely important, and it'll stay that. We want to be available on all major OSs, and we want to make sure that when the operating systems change, that our users don't have to worry too much about that. We're taking that work of porting Qt to a new operating system for you. Also, Qt is a horizontal framework, an offering, and that works across different things. I said we have an embedded version, so we're working from very small embedded devices like this car instrument cluster implemented on an IMX6, to large desktop systems. What you see here is Autodesk Maya. They're using Qt for their tooling. They actually even have a developer community of their own around it that also uses Qt, so they're exposing plugin interfaces where people can in Qt write their own plugins to Maya and plug them into their framework. And we have also large distributed systems like some of the European air traffic control systems that are also using Qt. So whenever you fly to Europe, think about that. I hope you're not getting scared about it. API design concepts. What are we doing? What's important for us when we design our APIs? The thing that's most important for us, and we have a slightly different focus probably than what you see in the standards committee and with the standard C++ standard library. For us, we see that code is written once, but it's read and modified many times. This goes back a little bit to the programming versus engineering that you heard from Titus on Tuesday. Most of our users are not doing throwaway code. They have a code, they need to maintain that over many years and read it again and again and modify it again and again. How can we make that easy? Because the maintenance is the larger part of work. It's more work than the initial development. And we all know that we're lazy. We rarely comment our code. So how can we make code self-documenting? So what we want really is APIs that lead to readable and maintainable code. They should be intuitive and self-documenting. That means we need to have descriptive naming. We are going, and if we can, for property-based APIs. We want to hide as much complexity as possible in the Qt implementation and don't expose it to our users. And we want to remove the need for boilerplate code as much as possible. The APIs should also be easy to learn and to use. We're trying to implement always one concept per class or per method. That API should do one thing and should do that well. I can tell you we're not perfect with that. We have our own dark corners where we're violating every one of these principles I'm naming here. But at least we're trying, and I think for the most used parts of Qt, we're actually pretty good at that. We're going with consistent naming, same name for the same concept throughout all of Qt, like a static polymorphism. We have, for example, the QString class and the QByte array class. They're doing similar things. One is an 8-bit byte array. QString is a Unicode string. But still, you still have things where you want to find substrings in there, do other things. You want to maybe uppercase, lowercase things, and these kind of things. So we name those methods the same way. And we do that throughout all of Qt and try to be as consistent as we can with that. Aiming and striving for clear and simple semantics that don't surprise anybody. And trying to make it so that you can do a lot with the class without having to learn a lot. Ideally, you rarely have to look up the documentation or learn things there. You can just look at the code completion. Okay, these are the methods I can use. Go with that. Make them hard to misuse. Our defaults should match the intuitively expected behavior from our users. Don't surprise them. So that makes it then easy to write and natural to write correct code. And it does encourage good programming practices. We also don't want to fail if methods should be independent of each other are called in different order. They shouldn't have subtle or hidden side effects. We want to avoid implicit conversions. We've seen that as a big problem, and we try to not do any magic. Stuff we've been all doing in the past ourselves. And of course, don't fail 3 calls later when you do something that's wrong. Qt APIs are supposed to be flexible and cover the common use case. We have a 90-10 rule that we say, well, the 90% use case is what 90% of the users want to do with that class. And that should be as easy to implement as possible using the class or the set of classes that we provide. And then it should be extensible. So the remaining 10% of the use cases which go beyond that, they have to be possible still. But maybe they require a little bit more work. Performance. This is one thing where we deviate also from what you know from the standard libraries. One thing the committee and then the C++ standards are very agreeing is you don't pay for what you don't use, right? We're deviating a little bit from that. we say of course we want to ensure as good performance as possible on all parts of the framework. But we also say we don't want to complicate the default APIs for performance reasons. Less readable code implicitly leads to more bugs. It leads to longer development cycles, takes longer to get your product to market. And most of our customers actually have time pressure. They need to get the product out. They have limited resources, so they want to get the product to market fast. And as you all know, 95% of your code base is not necessarily performance sensitive. So if it's a couple of percent slower, it doesn't really matter at all. And we're seeing that users will use a complex API often the wrong way. So a simpler API does actually, on the user side, often lead to more performant code, even though they could do it even better if they had the more complex API. But then they would probably use it wrong, and it wouldn't work anyway. But we do as much as possible, of course, go the extra mile to create APIs that are both as fast and as simple as possible. And where we require, offer low-level access to optimize critical paths. But we want to really keep it simple, as I said, and make it easy also for new and intermediate developers. C++ has a very steep learning curve. And that makes it often a little bit hard to get started for new people. We know, especially, if you have a student coming from university, he's worked with Java, you can bet on that they will, for example, pass objects by value to functions, because that's what you do. And we're seeing that a lot of the projects really don't only have C++ gurus. If they're lucky, they have one who really knows C++ inside out and can help with these things. Often they don't have anybody. So C++ is complex, but most of the complexity is actually is only rarely required for people. You would rarely see an application developer fiddling with template meta programming. Usually it doesn't happen. They will shy away from that. And with that, you can make 99% of the code self-explaining and easy to write. The other thing is that code, as I said, also often lives a lot longer than originally planned. There's code that was written for these kind of machines that's still running, in business-critical parts of systems today. Usually using an emulator of the old machines, but it's still running, and I've seen that myself. When I was doing my PhD thesis, I was working actually in physics at a facility in Heidelberg with an accelerator, and the controlling software was written for PDP-11. 1970s type of computer. And yeah, in '99 when I did that one, that was 25 years later. It was still running that, and they had problems because that machine broke down, so they needed to put it onto an emulator. That one was running way too fast because it was depending on timing loops, and they had to do all sorts of crazy things to get that working. So the software is often running very long, and we need to make sure that people can live with that. They can bring the software to the next, into the next decade. And we know that computers are changing. In '95, you had desktop computers. That was the main thing. You had some workstations, and you had high-end things. Nowadays, all of us, we have a much more powerful computer just in our pocket. And people want to develop for those computers, for mobile devices, and for lots of the embedded devices. So for us, it's important that we isolate our users from those platform changes. And we do that by bringing Qt to new platforms, but also by providing stable APIs. We are striving to have source and binary compatibility within major versions, and from one major version to the next. We do need that from time to time. Every 5 to 7 years, we've been moving from one major version to the next one. We need to do that to keep Qt alive, to take new concepts into use, and to clean up old things that actually don't make sense anymore. But we still always need to make sure that we have a good path for our users to move with us forward and minimize the API breakages there. A lot of that can also be avoided if we, from the get-go, do a lot of work to make the APIs as good as we possibly can. Okay, let's have a look at the implementation. What are we doing there? well, clear naming is once. We don't use any abbreviations for function names. We prefer typing them out. Your code editor can help you and offer you the completion, so you don't have to type it all. And it leads to much more readable code afterwards, which makes it easier to maintain. No Boolean arguments, for example. We use enums instead wherever we can. And we make sure that each method does one thing, but does that one well. And it's orthogonal. I'll show you an example of one thing that we had wrong in Qt3. We had a find method in our QString class. Now, it's, who of you has an idea what the false there means? Case sensitivity, yes, but it's not obvious. Who of you, and is it obvious what the method returns? Not quite neither. Does it return an iterator? Does it return an index into the string? Does it return actually the found string? You don't know. Have to look up if you look it up and you look up the declaration, you'll find it returns an integer, so probably an index, and the bool is the case sensitivity. In Qt4, we changed that. We said, no, this is not a good API. We want an API that's intuitively readable, when everybody who reads that for the first time, even if he doesn't know Qt, knows what it does. So we changed the API to index off, so it returns an index inside the string. And we changed the Boolean flag to be an enum, case insensitive or case sensitive. Much easier, and suddenly the code becomes readable. And you don't need to look this one up anymore to know what exactly is going on. We also moved over to more property-based API. We're doing that especially for our high-level graphical objects wherever possible. Because it's a very intuitive model, and you don't enforce any specific initialization order. You have defined default values. You can query those properties, and they're orthogonal to each other usually. Also here an example, a bad one from Qt3. You instantiate a Qt slider, basically a GUI control to slide between two values. Now I'd be surprised if anybody really knows out of their head what all of those values, all of those parameters mean. I don't. So also that we changed, and in Qt4 and Qt5, this is how it looks like. We say we create a new slider. Okay, Qt vertical, we can put that into the constructor because it's easy to understand. We're setting the range, we're setting the current value, and we're setting an object name. And suddenly the code becomes readable. And anybody who comes in and has to go in to fix something in that code base, sees it for the first time, can actually work with that one. And knows what it does without having to look up documentation. Or even if you look up the documentation of that slider constructor with 5-6 arguments, you still have to count to see which one does what. QObject, the base for most of our more complex Qt classes. I mean, this one is actually also interesting. It's pointer-based. So you create them on the heap. They're designed for subclassing. You can't copy them. And that was something that was introduced in the very beginning already with Qt. We have a memory management where we use a parent-child relationship, and that maps very well to graphical stuff. You have a widget on the screen, and inside that you place other widgets like a button and a line edit and other things. And usually, when you want to get rid of that whole widget again, you just want to delete the outermost one, and everything else is supposed to go away with it. And that's something that we did there. You can't have circular references, so it makes for a very simple memory management model, and that was even before we had things like smart pointers or anything like that in C++. We have signals and slots in there, really important for encapsulating those objects, make them more independent and loosely coupled, so you can connect a signal from one object to any slot from another object. And the slot will get called whenever that signal gets triggered. Properties and support for runtime introspection are other things that we added there, and because we needed them for many different things, and they fell out from themselves out of the RQ support for signals and slots. As said, signals and slots facilitate coupling. It's one of those places which removes a lot of glue code that you used to have otherwise. They're type safe. if one object gets deleted, connections get disconnected. So it's really safe and something that was really first deployed in Qt. I know that there are quite a few other frameworks now to do the same thing. There's boost signals, for example. But one of the things that we still have is that they're also thread safe and they work across threads. So what you can do is you can connect objects from different threads with each other. And inside threads, you'll have a direct connection usually, meaning a direct function call. Between threads, we'll just post the thing over to the other thread, and it's more like a message passing. But it makes it for a very easy inter-thread communication mechanism, and a safe one. Here's an example. You might have seen that one. We have the QObject macro. That's the one thing we need in there to implement our magic. It's also what identifies that QObject for the meta object compiler. I'll come to that one in a minute. We have properties, we have signals and slots. Very simple and also very readable. And you're seeing that we're extending C++ to some extent. And that's one of the things that people have been in the past criticized. I mean, we have signals and we have slots as keywords here. Nowadays, usually we have to write our header files using ugly q_signals and q_slots macros, but you can still write them this way if you so choose. And it makes for more readable code. It's also as said, one of our goals, keep the code readable. It can connect. We've had, in the old times, a connect system where basically things were done string-based. So signal and slot were just macros that basically converted the argument to a string. And then they were passed into the connect function, which looked those up. As I said, we were generating introspection information, so we knew which, we could resolve from a name, we could resolve the function pointer that we needed to call or connect with. In Qt 5 now we also have type-safe connects using modern syntax, like that, or you can also connect, of course, to lambdas these days. And as I said, there's different types of connections. You can make them direct, you can make them queued, so they come so that the control returns to the event loop, and the event loop then at some point notifies the slot. And you can make them automatic, which means direct, if you're in the same thread, queued if it's between threads. One of the questions I'm always getting is, why are we using the mock? Mock is the Qt meta object compiler, which actually, parses our header files and generates the data we need, to be able to implement the signal slot and the property system. It emits that metadata, it emits introspection information. And the big advantage we're having using it, as opposed to, for example, a mechanism that doesn't use that, is that we do have dynamic introspection information at runtime available. We can look up a method by name. We can look up properties and enums by name. We can convert between a string representation of an enum and its value back and forth. We can invoke methods. And, if you're using a decent build system, if you're using CMake, if you're using QMake, mock is completely invisible to the developer. You don't ever see it, actually. The build system will take care of mocking the files it needs to mock. It will take care of compiling the generated C++ files and linking them into the final binary. So that's fine. It doesn't really cost us a whole lot to have that available. And it really simplifies usage and makes a lot of things like, what I'll come later to, the Qt Quick technology for user interfaces possible. Value classes is the second set of classes that we have. Most of Qt's low-level classes are value classes, like we have rects, font, qstring, qvector. Mainly data structures with methods. There's no virtual methods, and ideally they should have been marked final. Well, when we implemented them, we didn't have a final keyword available, unfortunately. And adding it afterwards is difficult because some people were actually inheriting from them. For good or for bad reasons, but they're doing it. They're primitive or implicitly shared, and our implicit sharing uses atomic ref counting. I'll get to that. So primitive, that one, point, You have an X and a Y, and you have setters and getters. Nothing spectacular here to see. I mean, those are some of our classes. And then we have implicitly shared classes, like, for example, our font. And the way we implement those is that we have, put all our data into what we call a D pointer. They're hidden, in a private header file, giving us a much more freedom to add and remove data members. And whenever you set something, the implicit sharing looks at the ref count, does a detach, i.e. copies the data if the ref count is not 1, and then sets it. Simple mechanism. Noteworthy, people have been asking us, oh, but isn't that expensive? We're using atomic ref counting and these kind of things. Yes, there is a little bit of an overhead we pay, but we see that it in most cases doesn't matter. I mean, there's usually not a contention on that cache line. Checking whether the ref count is not equals 1 is something we can do non-atomically. Because if it is, we want to know if the ref count is 1. If it's 1, we are the only copy, we're the only user. So we can do that load non-atomically. So the only atomic operations we need to do is the increment and the decrement on copy or on destruction. The advantage we're having is that they behave really almost exactly like primitive types. They have copy semantics. They're easy and fast to copy. So, the mistake that many of our users do is, or many users do, is pass, these kind of objects by value, especially when they come from a non-C++ world and not by const reference. And with that, I mean, the things get actually a lot cheaper, and they're thread safe even if the data behind is shared. So I can create a copy of a vector, hand that copy over to another thread, and as long as the data is shared, we can still use them together. So that's great. There's a little bit of problems also, of course. There's a bit of a performance overhead. We have slightly different iteration semantics because they could detach when you use non-const iterators. And range 4 can also be problematic because it can detach. That's something that got added in C++11 after we had all of those available. Another large part of what we have been doing in Qt is filling gaps in the standard libraries. And for largest time, that was also needed because there was nothing happening on the standard evolvement. QString, C++ still doesn't have any real Unicode support. I think that's a huge gap, and it's actually something where we're lacking out to many other frameworks or many other programming languages that have that built in. Locale handling, date time zone handling. For the largest time before C++11, we were using atomic instructions. C++ didn't really have anything. Threading was also just POSIX threading. So we were doing our own stuff there, even though nowadays we could move over and use the C++ classes. But the classes are there, they're widely used, so removing them is also not that easy. We have fine handling, I&O networking. I know that's also coming now. And of course graphics, where the C++ otherwise doesn't really offer anything. And let's move over to that one, creating user interfaces. Two offerings, we have talked about that a bit before. We have the widgets, which are C++ controls that you can use and create. And we have the Quick UI technology to create more animated, touch-based user interfaces. QWidgets, here's the simple Hello World example there. Nothing special. Many of you have been using Qt, so you've been probably writing those lines in one way or another. Now we create an application, we create a label with Hello World, we show it, and let the event loop run. We have the graphical designer. I showed that one before for QWidgets. So making it easy to put those together. And then, of course, we have Qt Quick as a technology, which we have been developing over the last years. And that is something where we do user interface design in a declarative way. It's written in a language that we call QML. It's not C++. We'll get to that. But you still write most of your programming logic, application logic, in C++, in Qt natively, and you just hook the UI up to that. So the UI is actually supposed to be a very thin layer on top of that. And we've seen people doing it wrong and doing everything up there in the QML level because you do have some JavaScript support in there. It's often, it doesn't lead to the best designs or the best performance. So it's a declarative language to define user interfaces. Actually, objects in QML are all Q objects underneath in the C++ world. It's very easy there to create bindings to properties, and we have some automatic dependency tracking in there so that bindings always stay up to date. I'll show you that in a second. States and transitions and animations are supported and built in, so it's very easy to create animated user interfaces and animations, and you can easily bind it to C++, JavaScript, and integrate custom C++ types, of course. And on the right-hand side here, you see a simple example of a hello world in Qt Quick. Of course, you need the C++ side to instantiate that Qt Quick object still, but other than that, I mean, you have a text element showing hello world, and I put a mouse area in there that you can actually, allows you to click that text, and we would then, quit the application. Very simple, straightforward. Why are we doing and using QML? And you see, as said, I mean, it has a built-in and a visible and represents the visible structure of the user interface in a good way because it's a visual tree as well, and you can do that and show that with a minimal syntax. We have property bindings in there, so you can write foo, some property like the width colon some expression. And we'll make sure that the relationship between the property and the expression always stays up to date. So if anything on the right-hand side changes, the property value will always get updated. So automatic dependency tracking and re-evaluation of those properties. That's very important because it makes it easy to write something without glue code. It's very easy to write, you don't need glue code, and it's actually also, that's another thing, it's friendly for UX designers. Here you also see a little bit of a screenshot. That's some controls that are also available. So you have ready-made buttons and sliders and whatever you need also available at your fingertips there for creating user interfaces. Can easily integrate C++ and QML. So you create a Q object basically. You have some property. You can create properties on that object. Important is here that I forgot. That actually you also have a notification when the property changes, the size change signal. So whenever the size changes, you should emit that signal as well. And then you can have a slot like, rectangle clicked. And you can basically instantiate that, instantiate a Qt Quick view, instantiate that object, and set that object as a context property, what we call it, with giving it a name on the view. And with that, you can then use that on the QML side. So we have that rect.qml, and we bind there the width of the rectangle to what we had on the C++ side, the my object and the size property of that one. So whenever that one changes on the C++ side, the width on the QML side will get updated automatically. And we have, again, a mouse area, and if that one gets clicked, we call back into C++, the slot in C++. So you get the callback in C++ and can work your way from there. That's how you can very easily integrate the two sides. Also on Qt Quick, we have a designer similar to the one that we had for widgets, and it's where you can put together your user interface in a graphical fashion, where it's integrated and easy to use. And you have also there a separation between the presentation and the logic of the user interface. Okay, let's move over a little bit into the outlook and the future. Currently, 5.9 is the current release, and I haven't gone into what's in there really. If you're interested, look it up. Currently, we're up and have 5.9.2. The interesting piece is that 5.9 is what we call a long-term supported release. Will be supported for 3 years to come. So that's probably interesting for you guys. If you start anything new, that's the one you want to use. We're having a 6 months release cycle, where every 6 months we have a new feature release. We have, of course, patch level releases in between. 5.10 is currently in feature freeze. We'll have a beta soon and the final in hopefully November. And 5.11 May, 5.12 probably November next year. And that's probably going to be the next candidate for a long-term supported release. And that's as far as sort of, the release train goes. I'm not going to go into too much into what kind of features we have in there, just a little bit of where our focus areas are. One of them is graphics. What we've seen in the past, I mean, a couple of years ago when we went to Qt 5, we thought, okay, OpenGL is the thing. We're having that pretty much everywhere. Yeah, well, it turns out things changed, and suddenly, the Kronos group came up with or actually first AMD came up with something with Mantle. Then, Apple started pushing for their own graphics API called Metal. Then the Kronos group came up with Vulkan. Windows, Microsoft's, DirectX 3D 12. And we also still have to support software rasterization some places. So we have a big amount of different graphics APIs that people might be using. And how do we abstract those is a big research project that we currently have. And the solution there is really, to provide a scene graph that you can use together and abstract it on a higher level. So you talk about materials, you talk about meshes, these kind of things, and put that and have support for that. We already have some support for different graphics backends in Qt Quick, and for our 3D APIs called Qt 3D, we have a lot of research ongoing how we can integrate that. We have one problem though, that because we thought OpenGL is the thing and we can use it everywhere, we've exposed a couple of those directly in Qt 5, and we'll need to figure out how to deal with that. Our problem, fortunately, and we'll find a solution. We have a lot of general work that we're ongoing, improve performance, reduce memory consumption all over Qt is always an ongoing process. Looking into, speech support, we're seeing that this is requested a lot by customers. I mean, they want to control also their graphical applications with speech. How do we integrate with digital assistants that are currently coming everywhere? What do we do, on the graphics side, on the 3D side with augmented reality, virtual reality? How do we integrate things there? There's a lot happening, so that's going to be important for us. And of course, also, a lot of things happening on the IDE side, graphical tooling. We're doing more and more work on code refactoring, making that easier. But then we have a big project also where, we see that there are more and more companies that, do the software in C++, but they need a solution for the graphics designers to work with the software engineers in a good way and easy way. The default workflow is that the graphics designer works in Photoshop, creates lots of things, creates some sketches, sends that over to a developer. The developer tries to implement it, doesn't get it quite right. It doesn't perform because on the embedded device, for example, because the hardware is not powerful enough to actually implement or support what the designer thought of. Then it goes back to the designer. You have very long development cycles because of that. So integrating designers in that workflow and enabling them to work directly on, for example, the target hardware with the real product is something that's important, and that we'll be putting quite a bit of effort into it. And things like graphical asset conditioning and other things that are important in that space as well. Okay, on the C++ side, we're using, since 5.7, we're using C++ 11 fully inside Qt. Well, not quite fully, I have to say, because we still have to support Visual Studio 2013, and that one has problems with, for example, const expressions. But as much as we can. And we want to start using 14 and 17 features as much as we can as well, because it would simplify code inside Qt, make our maintenance easier. We're currently still limited by many of our users using older compilers. So they'll come, but we're usually living a little bit behind the bleeding edge there. But we're already doing certain things. We're using has include, for example. We're using the deprecated fall-through attribute annotations, hiding them behind macros, which expand to nothing in case the compiler doesn't support it. We've added a string view class similar to standard string view, but working on a QString, and make other things that help that we integrate as good as we can with the upcoming standards. I think the one that's going to be really important for us is then C++20. That could become really interesting. Concepts for better diagnostics and error messages. I know that a lot of our users are struggling with those. Having modules, we would really need those for our code models in the IDE, for compile times. But we do need, so that's something to remember. We do need some sort of macro support in there. And I know that some people don't want that in modules. We'll need it, otherwise we can't use them. Now, to which level is a different discussion, and that's something we can have. And I'm really looking forward to having a reflection and also the Herbst meta-programming things come somewhere closer to a standard. It would be fantastic if we could get at least some sort of subset, some first start of that one into the next version of the standard. Because, honestly, I would love to get rid of our meta-object compiler of mock in the long term, if we can do it. And I would really love us to see to reduce the need for template meta-programming a lot. So, with that, here's the cute logos that we had over the history. We've evolved a little bit, flat, and that's the one we have currently. And with that, I'd like to conclude my talk. Thank you very much for your attention, and I think we have a couple of minutes for questions, at least I hope so. Thank you very much.
Thank you for the talk, Lars. I have a question about the subject that you probably didn't cover. What about the security of Qt?
Security. Yes, I have a focus on that, of course. We're trying to make sure, we have code reviews. We do, a lot of work trying to make sure that we find any issues. I've had actually a good chat here with a person from Google about, fuzzing. That was you, right? And these are things we have. We have a security mailing list. We do get relatively few issues, I have to say that. But we do get them from time to time, and we handle them, of course, with, quickly. So we have a policy there, closed mailing list for security issues, trying to handle them, and we then also, disclose them with security advisories and patches and updates. Please.
Is it pronounced Qt or cute?
That's a good question. Okay, so everybody inside, Europe says cute, at least from our side. I know that in the US, Qt is externally the more prevalent pronunciation, but we're saying cute usually from everybody who works in the company and everybody who works with it closer. So all the contributors, I think that's the going name that we're going for.
Thank you.
First of all, I'd like to give credit to Qt for QML, which works really slick. Also, I'd like to give credit to you for being brave enough to tell C++ community that 2-3% may not differ in performance. Maybe brave. But I have a question. I program in Qt daily, and sometimes I feel like the Qt and the C++, they differ, they diverge somehow. And being a C++ programmer feels different than being a Qt programmer. What are your thoughts on this for the future? Like, you have QVector, you have a lot of duplicates.
Yes.
Like these to merge or somehow?
Ideally, yes. Now, the problem is, of course, there's a couple of issues that I'm seeing. First of all, the obvious one, there's lots of people out there using the existing classes. You can't just, throw those away and tell everybody to port over. There's a lot of work involved, and most people don't want to, invest that work unless we offer a very good migration path. Secondly, there's a couple of classes where we do believe that we offer a better and easier to use API, and yes, it does feel different sometimes a bit, but I mean, C++ still doesn't have any, we've been asked to give up QString because why not use standard string? First of all, that one's 8-bit. Okay, we could use UTF-8 in there, but it doesn't have any of the Unicode functionality, uppercasing, lowercasing, anything you need. So we can't really give that one up. Now the main question comes around some of our container classes, vector, lists, and hashes, and others.
So on.
And there it is a valid question. I mean, from my point of view, I'm always saying, use the ones that suit you best. There's some advantages with using, for example, a Q vector. Because of the implicit sharing, it's very cheap to basically, take a copy, move it to a secondary thread, that copy. If you take a copy with a vector, even though that other copy only needs read-only access, you're still copying all the data. So depending on your use case, I mean, one or the other might make more sense. I think it's fair to just use both and to use whatever suits you best.
Thank you.
Sure.
My question goes in the same direction. When will we get rid of the owning raw pointers that we have right now in Qt in the API? And that should, frankly, be replaced by smart pointers or something else.
The problem is, the problem is a problem of compatibility. How much, do you break of your users' codes? I mean, there's probably billions of lines of code out there written with Qt. How much of those lines do we want to break? So ideally, we need to find strategies to offer transitions and to, methods for people to transition to non-raw pointers. That said, I mean, even if we, sometimes we return raw pointers, you can always put them into a smart pointer or something like that on your side, right? Or a unique pointer.
Yes and no, but usually, like, you create an object, you do that directly in the smart pointer, then you hand it to some Qt API that reparents it, and then, like, between the line where I called the Qt API and where I can, like, reset my smart pointer, there is an area where basically two objects own the same thing, and that should not happen.
Yeah.
And there's no way around that problem right now.
Unless you take it out of the smart pointer beforehand, yes.
Yeah, but then you have it the area where nothing owns it before it. So that's
yeah, I see the problem. As I said, I mean, it comes from the history, and it's not an easy one to solve. But we'll have discussions over that. But don't expect any very quick fix for that, because it probably also would involve breaking certain APIs that we're currently having. That's not something we have to be cautious about, at least.
Thank you.
Sure.
If your code is open source, where does the company's income come from?
As I said, we have a dual licensing model. We offer Qt both under open source licensing terms, LGPL and GPL, and under a commercial license that people can come to us. They can buy that one from us. They get commercial support. There's a lot less strings attached to it than with the open source version. I mean, because LGPL and GPL also still give you some obligations that you have to follow, and not everybody might like those obligations. So we're saying, the model behind that one is saying that basically with the open source version, you're helping us expand the ecosystem. If you don't want to do that, you can buy a commercial version, and with that one, fund the further development of the product.
Okay, thank you.
You're welcome. Okay, over there.
You're first.
Okay, go ahead.
Okay, so it's basically a follow-up on the question before. The main reason I think that there's a lot of pointers involved in Qt is that the Q object inherited stuff doesn't have move operations. I mean, yeah, in C++ 17 the problem a little bit goes away, but right now you can't really return Q objects or the real type of them by value from functions. So you have to allocate them on the heap, pass around pointers everywhere. Is there plans to change that, like at least move semantics? Because it makes sense to move objects around I can understand it doesn't make sense to copy objects that have connections to some other stuff because no one knows what should happen to the connections. But if you move it around, I don't see the problem.
Well, it might actually. The thing is, I mean, that if we look at the implementation, we're anyway hiding all the data behind the D pointer. In principle, if I was to design this anew nowadays, I mean, all of those would actually, probably get, some more of a value semantics. But, we've designed this 20 years ago or more than 20 years ago, and so we'll have to somehow deal with the heritage. It could be a possibility to see whether we can provide move semantics. That might be possible, but I'd need to look into it.
It's definitely possible because I've implemented several wrappers around queue objects that do the moving. But for now, I can only do it non-generically because I'm not in part of the meta object compiler. So I have to know the signals and slots that the object has to do the remapping of the signals.
Yeah, that's a little bit the problem. If you move it, we'd need to change some of the internals to work, to basically hold the private data pointer. That one is never moved anyway. So that would then the things could be easier. But yeah.
Yeah, but are there plans to do that?
Nothing concrete, but I mean, it's an open source project.
Yeah, okay.
If you have good ideas how to do it, more than welcome to get yourself involved.
Yeah, thanks.
Sure.
I have sort of a two-part comment on that question about where you answered with QString. Do you actually have benchmarks that show that the copy on write model is better, especially in the context of GUIs where strings are super short and cheap to copy? Because it seems like to me that the lock would be way more expensive than...
There's no lock. I mean...
Well, if it's copy on write...
Yeah, it's an atomic operation, I mean, that we're doing, and in most cases, I mean, it's an atomic increment for the copy.
Yeah.
We have done some benchmarks, I mean, and for very short strings, I agree with you, copying them would be faster. The problem is we didn't know those, but we have some work in progress patches. I know that one of our developers, Thiago, he has a patch for us for short string optimizations where we would basically put them directly, don't even allocate a D pointer and basically just copy them all the time for short strings. So we have that somewhere. It would break binary compatibility. That's why the stuff hasn't landed yet.
Yeah, and this, the argument for the Qt containers that keeps coming up is the Unicode support in QString. I believe there is a standard string compatible working Unicode support in CS string, which is probably going to be standardized at some point. Is that something you guys would get behind?
CS string is QString. I mean, CopperSpice forked from Qt and then basically used QString and made it a CS string. I mean,
it's got the standard string interface, right? So you don't have the divergence of communities over.
It can't have just the standard string interface because standard string doesn't offer you many of the other things, and many of the, at least the most important methods from standard string, I think we do have. And if they're still not there, we can discuss filling them in, but you do need more than that, right? You do need, case conversions. You do need many other things that you want to have from Unicode.
Yeah, but I mean, okay, you could patch in a locale mechanism, like the case conversions and at least in my opinion, even things like finding within a string shouldn't be part of the public interface of the string. They should be free functions anyway. So I don't really see them missing in the public interface of that object to be an argument against it.
Once again.
Well, you're arguing that the public interface of standard string isn't rich enough to express everything in QString, right? Or what is the argument against a interface compatible?
I'm saying we can keep it we can probably make it compatible.
Yeah.
But we will need extensions on top.
Yeah.
On top of of what the interface of standard string is.
But the way to do that is free functions anyway, so I don't. Yeah.
It might not be a problem. I'm just saying that it can't just be the standard string interface.
Yeah, but the point is, it seems like it's a conscious divergence between the Qt community and the standard the rest of us C++ guys?
It's a divergence that has evolved over the years, right? Over many years. Some of them has been in the past conscious because we were looking at when we did, for example, Qt 4 at APIs and trying to really find good and intuitive APIs, as I discussed earlier. We have been then also adding a lot of things that are compatible with the standard classes to make them more compatible with each other. But it's also difficult to now go in and say we just move over to whatever the standard has and remove everything that we've had so far because we make so much code out there. So it's not an easy thing to solve. I mean, you can just say why don't you just move over and then I would start using Qt. But you shouldn't forget that there's, as I said, there's a huge amount of users out there whose code we would break if we remove those methods.
Yeah, but you've broken a lot of stuff in a lot of versions. I mean,
from Qt 4 to 5, very, very little. With the one place where we broke a lot of things was from Qt 3 to Qt 4. That was in 2005, 12 years ago.
But most of those were getting rid of singletons, so it's okay.
So, usage has multiplied since then. Okay.
Hi, great talk. I just had a quick question. You alluded or kind of gave us a brief overview that the Qt team is looking into using other graphical, languages or frameworks. I was hoping you can tell us a little bit more about the research you guys have been doing, and just maybe if one of the frameworks kind of lends itself easier to be used underneath Qt, or just any insight into that?
Yeah, well, I mean, we're talking about the 3D APIs that are now being pushed by different vendors. I mean, Apple pushing Metal, Kronos pushing Vulkan, Microsoft Direct 3D 12. The problem with all of those is that they're targeted mainly, at game developers to a large degree. They're very low-level APIs, which means you have to build up a lot of stuff on top of them, and that is quite a bit of work. I mean, there's nothing fundamental that's keeping us from supporting them. We have, for example, done for the Qt Quick scene graph, we have a backend for Direct 3D. Nowadays, it's mostly, it's not 100% functionally equivalent to the OpenGL one, but it's very close. And that we're doing more research there. It's a question to some extent of finding the right abstractions and defining those, and then the other part is just work to implement that. And they have been spreading so far, so many different APIs. So it's a lot of work to support them all. So we're doing things in stages as we see the needs from our users.
Thanks.
Sure. Okay, thank you everybody.
Bash Films can shoot your event with multiple cameras, link to presentation slides, add titles, and edit your event live for a full broadcast experience.
How is this even working? So this is actually a more interesting program to look at in a lot of ways. So let's profile it. Give it a little bit of time to do a profile for us. Let's see exactly what it is that's making this faster or slower based on the different inputs. I mean, you can really gain a lot of insight by actually looking at the profile like this.
I worked at Sesame Street. I got brought on to be a writer's assistant on a show called Sesame Street English, which was to teach English to kids in China and Japan. It seems very simple, the shows that they put together, but it's actually really hard to design a show that is not only for young kids, but also the parents.
Confession like this is therapeutic. I hope you all get something out of this, but if you don't, the therapy will have been good for me, so thank you. 7 years ago, I was working I wasn't working at Google. It was for my previous employer, which was a large multinational investment bank. I had what was up to that point the worst day of my career.
And then came the anger at ourselves because we knew we were responsible for America's first space disaster. We wrote 2 more words into our vocabulary as mission controllers: tough and competent. Tough meaning we will never again shirk from our responsibilities because we are forever accountable for what we do. Competent will never again take anything for granted. We will never stop learning. From now on, the teams in mission control will be perfect, because as a team, we must never fail.
One other thing. we're all in a very fortunate position. We've been very lucky in our lives and so forth. And I think as part of the mission, it's also good sometimes to take that fortune and give back. To make sure that you take this platform and use it towards worthy causes. That's good karma. That's good stuff in the universe.
We understand that your event will have needs that are specific to your organization. Please email or call us directly to discuss your particular event. We look forward to discussing your goals and helping make your event a success.